So if 10 people are to be seated on two separate round tables, illustrated out here, one with 6 seats and the other with 4, how many possible seating arrangements are there? So before we proceed, you may first try this one out on your own. Okay, good. Let's begin. So to solve this problem, you just need to visualize how it would work in real life. So let's say if we have a group of 10, if we have 10 people, and our goal is to arrange these 10 people out here. The very first thing that will be decided upon is who sits at which table. So let me write that one down. That is, so out of the 10 people that we have here, how would we allocate 10 of them or 4 of them to the 4-seater table, and how would we allocate the rest of them to the 6th table? So to do that one, the key is to use the combination formula. So we'll be having here 10 choose 6. So again, the idea is out of the 10 people, we'll be deciding in how many ways can we decide to choose 6 out of them to be seated, and then the 4 will be allocated correspondingly. So this is given by the formula 10 choose 6. Yeah. So note here that recall that in combination formula, this one is just equal as well to 10 choose 4, which makes sense if we reframe the problem of out of the 10 people, we'll be choosing we'll be instead deciding how many ways we can choose 4 people out of that. But for this case, we used instead the idea of out of the 10 people, in how many ways can we choose 6 people out of that. And then from here, just recall the combination formula. So that is given by 10 factorial, then 6 factorial here to represent this. And then the remaining one is just 10 minus 6 factorial, which is just equal to 4 factorial. There you go. And then let's just solve this one. So to solve this, take note that 10 factorial can be written as 10 times 9 times 8 times 7 times 6 factorial. This will be all over 6 factorial. So the 6 factorial here would cancel out. Then 4 factorial can be written as 4 times 3 times 2. So the 4 and 2 would cancel out the 8. The 3 here would cancel out the 9. So we'll be left with 10 times 3 times 7, which is just equal to 210 ways. So I hope you were able to follow that one. That's just quick solving, I guess, I would say. So let me just rearrange this one. There you go. So that is the first step. Decide on how would you split the group. Then from here, once you have decided upon the groups, the next thing to do in real life is to arrange the people at the table. So let me write that one down. So what that means is that now that we have 6 persons here and 4 here, our goal is to decide on how would they be arranged in each of these seats, and the same goes for here. So for a round table, the key is to recall the following. For a round table, the number of distinct seating arrangements for n people is given by n minus 1 factorial. Okay, so the idea here is that the minus 1 here appeared because of the rotational symmetry present in a round table. So for instance, if this one is person 1, 2, and 3, and 4, it would be the same if we have here like 1, 2, 3, and 4. And that is not true in a linear fashion, but for a round table, this is true. Okay, so for the first table, for the 6-seater, applying the formula, we'll just have here 6 minus 1 factorial, which is simply just 5 factorial. And this one is easily solvable to be 120 ways. Similarly, we do the same for the 4-seater. So for the 4-seater, we will have here 4 minus 1 factorial. This is just equal to 3 factorial, and this is easily solvable to be 6 ways. Good. And then from here, let's just visualize again in real life. So again, first step, out of the 10, choose the 6, choose the 4, allocate the 6 here, allocate the 4 here. And once we have decided on that, then it's done. So actually, these are all the ways that we need already to compute the total possible seating arrangements. So the last thing to do here is to just simply note that these events are independent. So recall that in probability or in combinatorial, when we have independent events, what we do is then we multiply. So again, the idea here is that if these things are independent or they are connected by the word and, or yeah, and. So the idea is this happens and then this event happen and this event happen. Then what we do is we multiply all the number of ways that happens. So we choose who sits at which table, and then we choose to arrange the people at the tables. Hence, to obtain the total arrangements, all we need to do is to multiply the obtained ways that we have. So 210 times 120 times 6. So I'll leave this to you to verify that upon multiplication, what you'll obtain is 151,200 ways. And this is the answer that we are looking for in this problem. There you go. So I hope you enjoyed that one. It's pretty straightforward if you just understand how it works. So just visualize what happens in real life when you need to decide on a certain arrangement. And then from there, you just use the necessary formulas to compute for the total number of ways. And just know that these are independent events, so we multiply. Yeah, so I hope you enjoyed that one and you learn from that one. If you have any questions or suggestions or even personal solutions, alternative solutions to this one, feel free to comment it down below. So that's it. Have a nice day.